If you know one of the six trigonometric functions, either sine, cosine, tangent, secant, cosecant, or cotangent, then you can actually find all of the other five. What we need to do is just kind of think about what is the information that cotangent of theta is telling us. Well, remember, so, ka, toa. What we have here is not sine, cosine, or tangent, but what we have is cotangent. Remember, cotangent is the reciprocal of tangent. So let's think about this for a minute. Tangent of theta is its opposite over its adjacent, toa. So what would cotangent of theta be? Well, that's the reciprocal or the upside down. So that's the adjacent over the opposite side of theta. Well, if we look at this right here, cotangent of theta is 2. How do we write 2 as a fraction? We can write 2 as a fraction as 2 over 1. But now I know that 2 over 1 is the adjacent divided by the opposite sides of the triangle to angle theta. So what we're going to do is we're going to come over here and draw a right triangle. And we're going to mark one of the angles as theta. It doesn't matter which one, but once it's marked, what do I know? I know adjacent to this, not the hypotenuse, but the adjacent side is going to have length 2. And the opposite side to that theta will have length 1. And now we can use our favorite theorem, Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. So c squared is equal to 5. So c will be positive square root of 5. And we have the lengths of all three of our sides of our triangle. Based on this, now I can find the sine and cosine and tangent of all of the parts that we have, of all of the of side theta. All right, sine. So opposite over hypotenuse. That's 1 over square root of 5. We got to practice that rationalizing. So we move the square root to the top, and the big bottom becomes the number under the square root. Cosine. Ka, adjacent over hypotenuse. That's 2 over square root of 5. The square root moves to the top, and the bottom is that number under the square root without the square root. Tangent is actually going to be the easy one because what is tangent? Well, it's the reciprocal of cotangent. So if cotangent is 2 over 1, then tangent must just be 1 over 2. Well, that wasn't so bad. And speaking of not so bad, don't we already know cotangent? We can go ahead and write that one down as 2 or 2 over 1. Now, cosecant, remember the cos go with the non-cos. So cosecant is the reciprocal of sine. Now, we could flip this guy over, but then we'll have to re-rationalize and it's complicated. So what we should do instead is reciprocal our original problem. If we reciprocal this one, then the square root of 5 over 1 doesn't need to be rationalized, and it's just square root of 5. Same thing with secant. It's easier if we reciprocal the original one that has not been rationalized and get that the secant of theta is square root of 5 over 2. And so we get sine, cosine, tangent, secant, cosecant, secant, and cotangent. All 6 trigonometric functions by just knowing one of the functions and drawing.